Assalamualaikum warahmatullahi wabarakatuh. We are Group 5 from TSP1A. Is going to present Chapter 6 Aromatic Compound. These are our group members. And these are the contents of our presentation. Task 1. Synthesis and reactions of organic compound. Here is the overview of question 5.
Okay, for the first question, the question asks to state the type of mechanism involved and explain why benzene is less reactive than cyclohexane towards coordination. Benzene, the type of mechanism is electrophilic aromatic substitution, while for cyclohexane, the type of mechanism is electrophilic addition. For equation of benzene, as you can see here, one of the chlorine will substitute the hydrogen here with the presence of aluminum chloride to form chlorobenzene and the byproduct Cl aluminum chloride. For the cyclohexane, the double bond will break and the chlorine will attach at the carbon here with the carbon tetrachloride in the dark to form 1,2-dichlorocyclohexene. Okay, the benzene is less reactive than cyclohexane is because benzene is stabilized by the localized of electron. So, it's tougher for any particular molecule of electron to make an attack to cause reaction. Cyclohexane contains double bond that has higher density. So, it's more susceptible to be attacked by electrophile.
Now for the next question, given that benzene undergoes physical acylation with ethynyl chloride to form compound A. Here is the reaction equation. Benzene reacts with ethynyl chloride with the presence of aluminum chloride as a catalyst to form compound A and HCl as the byproduct. So here is the structure of compound A. This is the parent chain which is ketone and it has 2 C, so the name is ethanol. But it has a substituent which is phenyl, so the name of compound A is phenylethanol. Phenylethanol is the IUPAC name and it's commonly called as acetophenone. Now for the reaction mechanism, step 1, formation of electrophile. The electrophile is CH3CO+. It is formed by the reaction between ethynyl chloride and aluminum chloride catalyst. As we can see here, heterolytic cleavage occurs between the C and Cl. Since Cl is more electronegative than C, it will attract all the bonded electrons towards itself. Then Cl will be attached to the AlCl3 to give intermediate looks like this. This C is now electropositive and Al is electronegative. This intermediate is unstable, so it will form the electrophile and the catalyst complex which is AlCl4- ion. Step 2. Formation of uranium ion. Benzene is an electron-rich molecule, so it is a nucleophilic site. This nucleophilic site will be attacked by the electrophile to form an uranium ion. The electrophile will attach to the C, same with H. The other C, which previously has the double bond, will now become positive. This electron will move here to make this C neutral. So here we have the double bond and this C will become positive. We will have another resonance structure where this electron will move here. So here we have the double bond and this C become positive. This three structure we call as resonance stabilized carbocation and it also can represent as this structure. Step 3. Removal of H+. This H will be removed by the AlCl4- ion and this electron here will move here to form the double bond and the product form of phenylethanol. HCl is the byproduct and the catalyst is regenerated.
Okay, for the third question, compound A, which is phenylethanol, reacts with a hot mixture of concentrated nitric acid and concentrated sulfuric acid to form only one product, and the name of the product is 3-nitrophenylethanol. Why only one product is produced? It is because COCH3 is a meta-director, which is a deactivating group. So, it will direct the new substituent to a meta position, which is 1, 3. Next, the question asks to suggest synthetic pathway to show how benzene can form phenylmethanamine. Okay, step 1. Friedel-Crafts alkylation. As you can see here, benzene will react with fluoromethane with the presence of aluminum chloride to form methylbenzene. The methyl group will substitute the hydrogen here to form methylbenzene. 2. Free radical substitution of alkyl benzene. As you can see here, methylbenzene or toluene will react with bromine in sunlight to form bromomethylbenzene. Bromine will substitute one of the hydrogen here to form bromomethylbenzene. 3. Nucleophilic substitution of haloalkenes. As you can see here, bromomethylbenzene reacts with excess ammonia in ethanol under reflux to form phenylmethanamine. Okay, bromine here will be substituted with amino group to form this structure, phenylmethanamine.
Now, we will move to the task 2, which is nucleic and alkyl component. Allah states that in Surah Maryam, verse 25, and shake the trunk of the dates palm towards you. It will let fall fresh ripe dates upon you. The chosen plant is dates. The functional group presented is carboxylic acid. Date palm, tree of the palm family Aracaceae, is cultivated for its sweet edible fruits. The date palm fruit is a one-seed fruit that usually oblong, but varying in shape, size, color, quality, and consistency of flesh. Now, we will move to the active component in date palm. The first one is one of the components that can be found in date palm is palmitic acid, or the IUPAC name for this compound is hexadecanoic acid. Palmitic acid contains carboxyl functional group. It can be found in date palm seed oil. The characteristics are hard and white or faintly yellowish crystalline solid, and a white yellowish powder with a slight characteristic odor and taste. The structure of palmitic acid is shown like this. The composition for one date contains 23 calories, 0 gram fat, 0.2 gram protein, 0.6 gram fiber, 6 gram of carbohydrates, 5 gram sugars, 0.1 milligram iron, 0.2 milligram sodium, 3.4 milligram of magnesium, and lastly 53 milligram of potassium. There are a few benefits of date palm. First, being an incredible source of protein, fiber, and vitamins. Great energy booster as it contains natural sugars like fructose and glucose. Help regulate a healthy digestive system. Helping promote a healthy nervous system. Reducing the risk of stroke and heart disease. Considered a superfood as it rich amounts of mineral and vitamins. For the reaction, organic ester can be synthesized by different methods. The most important method is the direct reaction of organic acid with alcohol in the presence of acid catalyst. Ethyl palmitate is produced by the esterification of palmitic acid with ethanol in the presence of sulfuric acid as catalyst. ethyl palmitate has a soft and waxy odor and is used to give a fragrance to saffron, cream, vanilla, and etc. These are the reference for this task. That's all from us. Thank you.